Hey guys, it's been a while. It's been more than a year since I've last made a tutorial. Of any kind, really. Sorry about that. Let's fix that by making a shader tutorial. I made a water shader tutorial more than a year ago. Way more than a year ago. Probably 2 years ago or something like that. And it was, it's alright. It was a basic water, sort of. A very simple water shader. This one is a bit more complex because it has transparency. And a lot more nice things like it won't clip awkwardly as you go up and down into the water. And it has nice smoothing to the edges if we're going to the water, and the distance, as you can see, it kind of has this nice smoothing to it. Hang on, let me just turn off the grid. So it has kind of like a fog effect underneath the water itself. That's nice. So let's make this thing. I've already tried to actually make this several times, so I don't know how to show this off in parts to make it easier. I think we should start off with the coloring of it. So how do we make it? How to make something transparent without actually using Unity's built-in transparency? Well, you use something called screen color. Grab screen color. This thing. Oh, hang on. Set the light model to custom lighting and unhook cast shadows and receive shadows. Set the cull mode to off and set render type to transparent and render Q to transparent. There. That's all you need. Let's start off with this. If we hook this up to custom lighting, and oh yeah, we gotta save the shader. Call it water. I already have one called water, but let's call it water. And let's make a material with the water itself. Water test. And click water, drag it onto a surface. It's already applying itself because this just grabs whatever the camera's rendering and puts it onto the material or the shader itself. So it's kind of, this is how you make transparency without using the built-in opacity of Unity's stock shader. So how do we make this ripple? Well, we gotta affect its UVs, and we do that with another texture or a texture map. The only texture map that we're gonna use called normal. Oh, normal map. Let's actually make the M big. Normal map. We're going to use two of them, but the second one is actually going to be a reference to our first one. Unpack normal maps, same with this one. Set it to bump and unpack normal map. We also need to affect the scale of it later on, but let's focus on the UVs, shall we? We need to affect the screen color with a UV. The screen position itself. Grab screen position. And if we just use this, it doesn't really do anything. This just puts a UV map across the entire screen, or uses the screen as UV space. So we need to affect this. We do that with the subtract. Hang on. Vector 2, X and Y, those are the only values we need. Subtract that with a value. Now the value we're gonna use is whatever this makes. So we're going to do lerp them together with a lerp string. Yeah, lerp strings, let's call it that. Max 1, default value 0.5. Set it to property. We're gonna use these a lot. Register variable. Call it normal map. Normal mapping. We already have something called normal maps, so let's not confuse the naming schemes, shall we? Make that a comment. Call it normal mapping. Same with this. This is screen UVs. When it's subtracted, it's then registered into screen UV. We use a get variable, or press G and then click. Get the normal mapping. If you plug this directly into here, you're gonna get problems. We need to first dial it down quite a lot with a variable called constant 0.1. There we go. It's not supposed to be a property, this is just a constant. Plug that into there, and then into a subtract. Now with this, press get variable and get screen UVs, plug that into there. Oh, hang on. Component mask. We need this first, actually. Forgot about that. Plug that into there, this into there. Unhook Z, so you just get X and Y. Now it's a lot better. Now that's hooked into there. Hit compile. And let's set a normal map. This one. Now it's already being affected by something, a normal map of sorts. Alright. So yeah, it's being affected by something, a normal map, but we want this normal map to be applied in world space and not the object space itself. Let's do that. I've got a cheat sheet over here. Let me just zoom out, place everything sort of nicely. So we got UVs and we got normal mapping, but we need to affect the normal map itself in world space. So we do that with a world position node. And we get the X and Z. Those are the only two that we're interested in. Plug the thing into a component mask, unhook Y, and let's add this and add time to it. That's the way we animate it. But we also need to affect the time parameters to our liking. If we want to animate it less or more, we're going to do that twice. Then we use an append node. Vector 2. Plug them back in. Add. Bang. There we go. And into these two multiplies, we're actually going to make a vector 4. vector 4. Or press 4 and then click, and it'll add a vector 4. Standard values of 0, doesn't matter. Let's call this one animate. Animate UV. Oh, hang on. Animate UV1 in X and Y. UV2 in WZ. Because we have two UVs that we need to create for both of these two. So X and Y to here. Now that should be enough to animate it, but we also need some tiling and some scaling. So then we multiply that and divide it. Multiply for tiling, divide for scaling. Create another vector 4. Oh yeah, the previous one set it to property. Same with this one, property. Call this one UV1 tiling XY scale ZW. Set the default values to 1, 1, 1, 1. Otherwise you're gonna get some issues. We need an append. An append node. Actually need two of those. X, Y, Z, W. This one into multiply. This one into divide. The reason why we have this one into A and this one both, it sort of linearly goes into A in each one of them is because if you don't, you're gonna get some strange issues. So just do this way, otherwise you're gonna regret it. Register local variable. This one is then called UV1. Now we need to do this thing one more time. So just duplicate it basically. Append. Multiply time into these. Do an add. Component mask. Add that. Multiply it. Divide it. And register variable into there. Make another one. Property UV2 tiling XY scale ZW. Default values 1 1 1 1 XY into append nodes, two of those. X, Y, Z, W. XY into there, ZW into there. Make it a comment, call it animated UVs. Now we use a get variable UV1. Oh, didn't name this one. UV2. Get variable UV1, put that into the first one. Get variable UV2, put that into the second one. Hit compile, check how it looks like. It's now being scaled in world position, so the entire texture is now 1 unit by 1 unit tall and wide. We go into our water test. We can scale it or tile it. Scaling is the last two variables. Wait, hang on. Did I do something wrong here? Yes, I did. Whoops. I did something wrong here. Sorry about that. don't think it did that for this other one, but yeah. X and Y is tiling, which, you know, 10 by 10, then it means it creates more of them. Compile. Yeah, now it's correct. 10, 10. Now it's quite large. The other one is small. And if we add some... It's now being animated and it's been blended together. So it looks kind of nice. There we go. Some hiccups. We also need different floats for these two scales. So normal map 1 strength. Copy it. Rename it to normal map 2 strength. Set them both as property. And set their value, default value to 1. Hit compile. We should also move the properties around. Yeah, like that. So now it's at least animated. It looks kind of nice, but we need some more things. What else do we need? Hang on, let me check my cheat sheet. So we need a Fresnel effect. A Fresnel and color. Let's start with color. So, no, not add. A lerp and color. This color, let's call this main color. I already have had one value saved in memory. Alright, cool. Let's just use that. Or we could actually make our own, I guess. There, that's decent. Now this lerp is going to be affected by different things, like our Fresnel. We could use a Fresnel. However, this doesn't play nice with double-sided geometries, so we're gonna make our own. Vertex normal. Do that by using a vertex normal and a view direction. These two and a dot. Those two together, boom. Now we have these are now this is a Fresnel. And we also need an absolute to make sure that it doesn't clip over, and saturate, and a 1 minus, and a power to a Fresnel power float. Set that as property. I like to set the maximum to 4, set the default to 1 to just 1. Let's plug that into X and the exponent. Register local variable. Make the entire thing a comment. Fresnel. Let's call it Fresnel. Get local variable Fresnel, plug that into alpha, hit compile. Now you have color. Looks alright, looks kinda like water. The problem though is that our Fresnel isn't being affected by our normal map. How do we do that? With the normal Fresnel node, you just plug it into the normal. if you have, you know, set to tangent normal, you could just hook up a normal map into here. However, we're not using that one, so we're actually gonna have to make this our own. Let me just move these out of the way, make room for more space, because we need it. Okay, unhook that. Make an append node. Come on. Vector 2, X and Y goes into that. Get local variable. We've already saved normal mapping, so we're going to use normal mapping again. Since we did that earlier over here, we're also going to use a component mask. Again, same thing. We don't need Z, we only need XY, and we do a divide. Again, either add or divide, it doesn't matter. Either way, it's, you know, it'll work. And another append node, vector 3. This into there, and the Z into the Z over there. Now that into B. Hit compile, and wait. Do I need an add? Hang on. Oh, it has to be an add, not a divide. Oh, divide, no, subtract. That's the thing. Subtract or multiply, it doesn't matter. So, wait. Yeah, subtract. I used it as a divide. Goodness gracious. Yeah, subtract, not a divide. Sorry about that. Now it should work. You see it's being affected by our normal map. So if we go back into here, hit compile. There, now the color is actually being affected by our normal map as well. Good. Good. Now we have normal mapping and we have transparency. But how do we make those nice looking reflections? Easy. It's called ambient. Oh no, wait, hang on. Indirect specular light. This is it. That's the cube mapping or reflections. So if we just plug this into the A instead of the screen color, doesn't really look like reflections now, does it? Well, that's because its smoothness is set to 0.5. If we set it to 1, boom, reflections. But we also need a normal, so get variable normal mapping into there and hit compile. Now it looks nice, looks good. You know, you have reflections. Good. How do we mix these two? How do you mix any lighting information with other colors or lighting information? You use an add node. Add them together. Plug it into A. Hit compile. Now you have color and transparency. However, I think I did something wrong here. Yeah, hang on. Other way, the color and the cube mapping should be added, not that. Again, you know, make some mistakes, rectify them. So there, add them together. Transparency and nice stuff. Good. Then we also need some fog effects. We do that with a depth fade. Register local variable, plug that in there. Depth, depth fade. And create a float, call it depth fade distance. And set it to a property. Set this, yeah. There we go. And with the Fresnel, we multiply it with the depth fade. Boom, boom, boom. Hit compile. Wait, hang on. Why is it acting all weird now? What's going on now? Why isn't it? Is it? Oh, right. Saturate. I was wondering about that. I thought, did I have to saturate it myself? But click the depth fade node, hit saturate, hit compile. Otherwise, it's gonna get a bit weird. So now you have Fresnel and you have a nice depth fading fog effect. But we're not done yet. We need to add some clipping. So we do that by using a camera depth fade. Another float, call it camera depth fade length. Come on, man. Camera depth length. And another one, camera depth fade offset. And a register variable, camera depth fade. Down in the multiply, get the camera depth fade. Oh. There. And hit compile. However, you see those weird color values. What's going on here? Again, it's the saturation thingy. This doesn't have a saturate. So you need to add it yourself. Saturate. Plug it in there, plug that in there. Hit compile. Fixed. Now, as you go down, you can see that it's no longer clipping weirdly. And you also have an offset, which I forgot to set as property. And the offset is basically just, well, it's an offset. Yep. Now you have everything you need for the shader itself. But we can make it better. You see, on the edges here, the normal map itself doesn't actually, or the affecting of the transparency, it doesn't fade off, sort of. So we can fix that with a multiply down here. On the strength of the normal maps, on both of them, get the camera, no, get the depth fading, plug that into both of them, hit compile, and now you see a nice fall off into for the affecting of the normal map. I think that was it, I think. So if we switch this into that. Yeah, they look the same. There we go. Hope you liked this tutorial. Hope it wasn't too advanced. Shouldn't be. And I hope it won't be another year until the next tutorial. Bye bye.